What if a farm could actually think for itself? I mean, not just follow a bunch of pre-programmed timers, but really understand what its crops need, moment to moment. Well, today we're looking at an incredible system called Eco-Gemma that promises to do exactly that. Let's dig in.
And really, think about that for a second. This isn't just about simple automation. It's about genuine intelligence. Instead of a farm that blindly follows a schedule, imagine one that could react, in real time, to a sudden heat wave or an unexpected downpour. That's the huge idea at the heart of Eco-Gemma.
Because as it turns out, a lot of what we call smart farming today isn't quite as clever as it sounds. In fact, it runs into three major roadblocks that keep it from being truly effective, especially for the people who need it most.
Okay, first up, you've got the problem of blind timers. These systems are just rigid. They operate on a fixed schedule. That means they might be wastefully watering crops right in the middle of a rainstorm. Or worse, they could be pumping out fertilizer during a blistering heat wave, which can literally scorch a plant's roots. Not so smart.
Then you have what's called the cloud trap. You see, most of these fancy IoT systems depend completely on the internet. Now, for a farmer out in a rural area with a spotty connection, what does that mean? It means their expensive, smart system becomes a useless plastic box the second that signal drops.
And the final nail in the coffin, the price. The professional industrial-grade controllers that can actually do this stuff well are incredibly expensive. We're talking prices that put them completely out of reach for small-scale farmers and those in lower-income communities.
So you've got these three massive problems: schedules that are too rigid, a dangerous dependency on the internet, and costs that are just way too high. So how do you possibly tackle all of them at once? Well, this is where Eco-Gemma enters the picture. At its core, Eco-Gemma is a smart agent that gets the context of the farm. It manages fertigation, which is just a smart way of saying it combines fertilizer and irrigation. It's not just watching a clock. It's actively sensing the farm's environment and making decisions. And the whole point is to be both super high-tech and super affordable.
This really innovative solution comes from project leader Tiz Mahad Sopian bin Abraham at IKBN Bandar Penawar in Johor, Malaysia.
So what is the secret sauce here? How does this thing actually solve all those problems we talked about? Well, the answer lies in this really clever design that you can almost think of as a two-brain solution. Let's just quickly walk through how it works. First, a bunch of sensors on the farm collect all the key data. Soil moisture, pH, the air temperature. That info gets processed right there, on site, by a little local server. Then, an AI model analyzes all that data and decides what to do, activating the right water or nutrient pumps as needed. And this is the core of that two-brain model I mentioned. It has one incredibly powerful brain up in the cloud for when it's online, but it also has a second, totally independent brain that lives right there on the farm, always ready to take over at a moment's notice. So let's break that down. When there's an internet connection, it uses a powerful cloud AI for really fast, complex analysis. But the second, and I mean the second, the internet cuts out, it instantly switches to a local AI model running right there on the farm. And the result? Absolutely zero downtime. The farm literally never stops thinking. Okay, so that's all the theory, but let's see how it actually performs when you put it through a real-world stress test. All right, so check this out. This is a look at the system's live dashboard during that test, and you can see a heat wave is hitting. The air temperature has shot up to a critical 35.8 degrees Celsius. For young crops, that is a huge, huge risk. Now, just remember, a basic timer system would just keep on blindly pumping fertilizer, and that would risk total disaster for the plants. So in this critical moment, what did the Eco-Gemma AI decide to do? And here is the absolutely brilliant part. The system's log shows us exactly what it was thinking. It actually explains, in plain English, that because of the high temperatures and low moisture, it overrode the schedule. It stopped the fertilizer and switched to pumping pure cooling water to protect the plants. It's not just smart, it tells you why it's being smart. That's something we call explainable AI, and it's a huge deal. And here's the real kicker. Even if you pull the plug on the internet right in the middle of this heat wave, that local AI brain takes over instantly. It makes the exact same life-saving call without ever missing a beat. The farm is always protected, no matter what. So you can see this isn't just some cool piece of technology. It has a massive real-world impact. I mean, this table really just drives the whole point home. Look at the comparison. A conventional timer has this rigid, fixed logic.
Eco-Gemma is context-aware. It uses real-time data. In a heat wave, the old system risks burning crops. Eco-Gemma intelligently switches to a cooling mode. And most importantly, where one is totally dependent on the internet, Eco-Gemma is completely independent. It just keeps working.
But this might be the most astonishing number of all. We're talking about the production cost.
The entire Eco-Gemma system can be built for under 200 Malaysian ringgit. Now compare that to those imported industrial controllers that can cost well over 1,000. This isn't just a small improvement, it's a complete game changer for making this technology accessible to everyone.
So when you put all of this together, the impact is just huge. It protects the environment by preventing all that fertilizer runoff. It ensures crop survival during crazy weather events like heat waves. And maybe most importantly, it democratizes this incredibly powerful technology, finally making it affordable and reliable for small-scale and rural farmers all over the world.
And this isn't just some lab prototype. There's a really clear path to get this out into the world, with things like kits for hobbyists, subscription services for bigger commercial farms, and even educational packages to help train the next generation of agri-tech specialists.
By solving those core problems of cost, connectivity, and context, Eco-Gemma gives us a powerful new tool. And so, it really just leaves us with one final question to think about. Is this kind of intelligent, adaptive, and accessible system the future of farming?